All right, so when we finished class on Wednesday, the last thing we had discussed was we had gone through the scientific method and we had said, okay, let's try to use this in an everyday type of situation. And the situation that we had decided we were going to work with was car trouble, right? So this is the instance, right, where you go outside, right? You put your key in your ignition and you go to start the car and the thing won't turn on. Okay, how do we use the actual scientific method, right, to fix this particular problem? Okay, and we had gone through the 5 main steps. We had said we start with our observations, right? We go into our hypothesis, right? It's where we make some educated guess, right, in regards to the observations that we had made. We then fall into the experiments category, right, where we try to use some method or some way, right, to prove that our hypothesis that is in fact correct. Okay, and then after we complete our experiments, right, we go through the actual analysis portion. So any data that we collect, right, or any result that we get, we analyze that. And this is truly the point, right, where we start to figure out, okay, well, did we actually run the correct experiments? Okay, also we may come up with some more observations. Okay, or we may find out that the analysis, right, really isn't helping things. Okay, so at this point, right, based on our analysis, if we make some additional observations, right, we're going to have to go back through the process. So potentially tweak our hypothesis a little bit, right, or do another set of experiments. Okay, and then finally, once we've gotten through all this, we come to some conclusion, right? And what we're really ultimately getting at is our hypothesis correct? Or is our hypothesis in fact wrong? Okay, so let's use this, all right, for this actual situation. Okay, so I'm saying, all right, I go outside, I put my key in my ignition and my car won't start. What is our observation in this case? Well, our observation is our car won't start. Okay, what is our hypothesis? All right, well, usually the first thing we jump to is that my car won't start because why, right? Usually my first thought is it won't start because the battery is dead. Okay, so what are we going to do to either help us confirm or help us negate our actual hypothesis? Okay, and so usually what we would do, right, or at least what I would do, is I would call somebody, okay, who can come over. I would get my jumper cables out of my car and I would have them try to jump start my car. Okay, so our experiment would be attempting to jump start the car. Okay, now, okay, based upon that experiment, right, we're going to make some additional observations, right? And what's our analysis in this case? Okay, so once we have ran that experiment, right, we're going to analyze the result. Go one of two ways, right? Either the car starts or the car does not start. Okay, so say in the instance, right, we go through it and we actually analyze the result, right? So the analyzed result is either the car starts or car does not. Okay? In the instance that the car starts, what can we conclude? We can conclude that my car did not start because the battery was actually dead. Okay, now what would our conclusion be if the car did not start? Okay, well, our conclusion would be the battery is not dead. And what would we then do? At this point then, we would end up repeating the entire process. Right? Now, what additional things could we do? Well, we could potentially go back and check and make sure that the cables are connected. Right? We could also have a bad battery. Okay, and usually in none of those, in all of those instances, right, if you do not end up getting your car to start, right, it's potentially another issue. So then you start working through the other things. Thus, the scientific method just continues to repeat itself. Okay, so that gives us an instance, right, an everyday, a truly everyday experience, right, where we would actually use the scientific method. And it's one of those things, right? We don't sit there and we just don't immediately go through, okay, what's my observation? What's my hypothesis? What's my experiments? What's the analysis? And what's the conclusion? Most of this is done as an intuitive process. So if we continue on through the material, okay, we're kind of now breaking away from, these are just the overarching themes of the course, right now to where we're going to start breaking down and going through the specific chemistry of things. So it's worth coming back and saying, okay, what is chemistry the study of? Okay, well, chemistry, very simply, is the study of matter. Okay, and what is matter? Well, matter is anything that has a mass and a volume. Okay, so what does that mean? That means if you take it and you put it on a balance or you put it on a scale, etc., right, you're going to get some tangible number that shows you that there actually is something there. Okay, what does volume mean? Okay, what's the easiest way to tell the volume of something? Does any, sit there and think about it for a second. Okay, if we're talking about the volume of something, say we fill a cup, right? We fill a cup with water, and then we go and pick a particular item up. Go over and pick up a bouncy, that's not a good example. Go over and pick up a golf ball. Okay, if you put the golf ball in, does the level of the water change? If the level of the water changes, right, then we can conclude that that particular item, right, actually does in fact have volume. Okay, so when we talk about matter, okay, so when we talk about matter, what we're in fact talking about is something that can actually be divided into two categories. Okay, so up here at the top, we have matter. Okay, and when matter breaks down, we actually have two ways that it can go. We have over here on the left are pure substances. Okay, and what really fits into this category? Well, here we have the most obvious, which are the elements, right? Those lovely trusty friends that are over there on the periodic table. Okay, and additionally, we have compounds. Okay, compounds are the pure form of multiple elements, right, that come together to form a known substance. Okay, and then over here on the right, we have our mixtures. Okay, and this is probably more familiar territory for us because most of the stuff that we work with or we encounter on daily basis, right, belongs in this actual category. Now, among the mixtures, okay, we have two different types. We have our homogeneous mixtures, and we also have our heterogeneous mixtures. Okay, and on the next slide, we'll actually go into to the actual description, right, of what sets all of these apart from one another. Okay, so come over here, right, and we start talking about what's on that left-hand side of the chart, right? The things that fit into the left-hand side, right, are basically kind of the phases of the matter that we're encountering. Okay, so when we're talking about things, okay, first of all, the main types of matter. Okay, so we're going to kind of alter the heading up here at the top. We're going to say the main types of matter. Okay, all matter can be broken down into the following categories. Okay, and what I mean by that, okay, is that all matter, right, will fit into one of these three, and there's a fourth that we talk about or we hear stuff about occasionally. Okay, but we're not going to really touch any of that in this class. Okay, so solids. Okay, solid matter. That is matter that has a definite shape and a definite volume. Okay, that means that regardless of what you put it in, right, the shape and the volume, okay, is actually going to maintain. Okay, now liquids. Okay, liquids also have definite volume, but they do not have a definite shape. And why we say that, right, is because liquids, right, they form into the shape of whatever we're actually pouring them into. Okay, so they're moldable to the container. All right, now gases are our last type that we're going to talk about. Okay, and our gases have neither a definite volume nor a definite shape. Okay, so it's always contingent upon what's going on around it, right? Volume changes with pressure of gas, right? Volume changes based upon the temperature of the gas. Okay, so that's really what we're talking about. All right, and additionally on the left-hand side, right, we have our elements and our substances, or our elements and our compounds, we already kind of talked about. Okay, so when we move over, okay, into the right-hand side, okay, the right-hand side, let's keep a few things in mind. Okay, first of all, okay, our more familiar territory, right, are our elements. All right, elements all contain atoms. Okay, what's unique about an element, okay, is that it only contains one type of atom. Okay, so that means that if we have bromine, right, and we have that in a vial, okay, that means that that's an element because the only types of atoms that exist in that vial are bromine atoms. They are all the same. Okay, so what is an actual atom? Okay, well, an atom is the smallest particle of an element. So what that means, okay, is that every single thing in there, all of those atoms are just the smallest part of the element, and all of those are exactly the same. Okay, so our compounds. Okay, compounds are the same, right? They're made of two or more elements. There can be three, there can be four. Okay, and somehow, through some process, they are chemically combined. Okay, and what does that truly mean for us? Okay, so if we sit down and we look at it, okay, it's all about bonding, okay, and that's something that we'll get into a little bit later. Okay, we actually get into it, I believe, in the next chapter and even a little bit in the fourth chapter. Okay, but what's important to it, right, is that compounds exist. There are groups of atoms that could be two or more types of atoms, and they're bonded together and they act as a unit. Okay, they completely 100% act as a unit. Okay, so our mixtures. All right, we said that we had two types of mixtures. Okay, the first type was our homogeneous mixtures. Okay, now what makes something an actual homogeneous mixture? Okay, well, the answer is probably not as intuitive as we would like to think that it in fact is. Okay, so, right, mixtures are a physical blend of two or more substances. Okay, and if it's a homogeneous mixture, what's unique about a homogeneous mixture is they are uniform throughout. Okay, now heterogeneous mixtures are not uniform in composition. Okay, so they're not uniform. That means if you take a sample of it, right, you're not necessarily guaranteed that you're going to get all of the same material in each sample as you would if you looked at a homogeneous mixture. Okay, so typically speaking, okay, give me some examples or think of some examples of homogeneous mixtures. Okay, the easiest way to think about a homogeneous mixture as an everyday example would be all of our liquid medicine, right? Those are actually processed, right? So we're getting roughly the same amount of each of the components of that mixture, which each sample that we're actually taking. Okay, now what about our heterogeneous mixtures? Okay, our heterogeneous mixtures, a good example of that would be soup, right? That's a mixture of 2 or more substances, right? Each spoonful that you get, you're not guaranteed that you're going to get the exact same amount of each of the substance. Okay, or what about some of our salad dressing? So like Italian dressing, right? Italian dressing is loaded with spices, right? It's loaded with herbs and spices. Okay, are you going to get the same amount of oregano in each sample of the Italian dressing that you get out of the bottle? Well, the answer is quite simple. It's no. You're not always guaranteed to get the same amount. Okay, so all matter, if we take a second and step back, all matter has a mass and a volume. Okay, all matter, okay, can exist in 3 forms, right? It's either going to be a solid, where it has a definite shape and a definite volume, or a liquid, where it has a definite volume but no definite shape, or a gas, where it doesn't have a definite volume or a definite shape. Okay, and we encounter matter, okay, as different types of compositions of chemicals, right? Or compositions of atoms. So what they first break down to is 2 main categories. So we have our pure substances, right, which are our elements and our compounds. And then we also have our mixtures. And within our mixtures, right, we have our homogeneous mixtures, which are uniform, and our heterogeneous mixtures, which are not uniform. Okay, and all matter has several things in common. Okay, they all have what we call physical and chemical properties. Okay, and our physical properties, okay, those are quantitative and qualitative. Okay, so when we talked about qualitative and quantitative observations, right, we already kind of touched on this. Okay, but we're looking at an actual physical property. Okay, what we're talking about when we're talking about qualitative properties are things like the smell, the taste, the color, the shape. We could also be talking about the appearance, or even the texture. Okay, when we're talking about our quantitative stuff, we're talking about our quantitative physical properties. What we're talking about are things like boiling point, or maybe something like density or mass or volume. Now, when we switch gears, okay, and we're talking about our chemical properties, we're talking about the types of interactions or the types of properties that different substances undergo, right, where we're forming new substances. Okay, so when we're talking about the formation of rust, right, that is a change in the chemical properties, right, of the starting material that we had before we started to rust, right? Because rust is in fact different, right, than what we actually started out with. Okay, so when we're going through this overall process, okay, some of the things that we keep in mind, especially when we're going around and trying to come up with our quantitative physical properties, okay, what we're talking about, right, are ways that we can measure matter. Okay, and some of these are going to be a little bit more obvious than others. Okay, and some of them are probably going to be things that you may have never heard of. Okay, so something common, right? Length. Okay, we often quantify things by their length. Okay, usually when we're measuring things, especially when we're talking about it in terms of chemistry or physical science, right? When we measure length, we measure it in terms of meters. Okay, and the symbol for meters is just a lowercase m. Okay, oftentimes, right, we measure things in terms of mass. Okay, when we do this, frequently what we're using as a unit or the standard unit is the kilogram, which is noted by the symbol kg. Okay, we also measure things in terms of time. Okay, and typically when we're talking about things in terms of time, We're talking about them in units of seconds, which are often abbreviated with an S. Okay, standardly, we measure things in terms of temperature. So if we're going to come back and we're going to say, okay, well, what's the melting point or the boiling point of a particular substance or mixture? Okay, what we're going to do is we're actually going to get this in terms of something that we call Kelvin. Okay, and typically Kelvin is noted by the symbol capital K. Okay, now some of these, okay, or the next few of these are actually going to probably be new for you. Okay, and they're new for you because they're truly unique to chemistry. Okay, but when we're trying to talk about an actual amount of something, okay, commonly the way that we measure this is in terms of moles. Okay, and we note this, or the symbol that we use for this is MOL. Okay, now among our last few that we have here, okay, we're going to talk about how we measure current, right? So this is something that a few of you in this class may have to deal with at some point, right? When you're working a particular job or you're trying to build a particular structure, okay? But when we talk about current, okay, usually the unit that we measure current in is called an ampere. Okay, and that is abbreviated by using a capital A. Okay, another thing that we sometimes do is measure the luminous intensity. Okay, can someone give me, or can someone think of and potentially share when we return to class, right, an instance where we would need to measure the luminous intensity of a particular substance, mixture, etc. Okay, and when we're measuring this, typically the unit that we use is a candela. Okay, and this is abbreviated by using the symbol CD. Okay, so this kind of puts into perspective, right, the different ways that we try to measure matter, how we try to quantify it, how we try to qualitatively come up with some kind of conclusion about it, right? Additionally, that tells you how it's going to break down, the different ways that we might encounter it. Okay, and it kind of gives us a bigger picture of what we're really talking about. And so what we're going to do, or what we're going to spend the rest of the time or this class talking about, okay, is basically how matter interacts, what we get from it, the benefits of it, understanding it on a more of an everyday type of level. Okay, so another thing that we will be gaining from this class, okay, is something that's not new to any of us, right? We all know that in order to get through daily life, right, or get through a lot of our classes, okay, what we're trying to do, okay, is be able to critically think. And one of the easiest ways to get down that type of approach to things, right, is by taking a science class, because science is all based upon critical thinking. So when we're trying to approach something, okay, and critically think about it, okay, or come through and take a statement and evaluate it and its claims in a very rational and objective fashion, okay, what we want to do is test it by using something called the Flair's test. Okay, and again, this is something that we're all probably very familiar with. We just may not necessarily realize that it's familiar territory for us. Okay, so the first thing we look at is the falsifiability. Okay, is there a way that we can prove that this is wrong, right? Is there a way that we can go out and we can say, okay, without a doubt, this is true, right? Is it something that there's exceptions to the rule, or is it something that we can conclusively say, yep, this works? Okay, the other thing that we want to look at is logic. Is there logic behind this claim, or is this claim just completely out of left field? Okay, was the claim replicatable? Okay, did it come back and were you able to reproduce it, right? We've already talked about reproducibility in science. Okay, is that a thing, right? Does that work? And also, the very last thing that we look at is sufficiency. So is there actually sufficient reason to this claim? Does it work, right? Is the explanation behind it sufficient, or is it just a claim that happens to work, right? that there may not be a real explanation for it. Okay, so when you're going through these, right, and you're evaluating a claim and trying to come up with if it's rational or irrational, okay, what you want to do is run through these 4 objectives. And if any of these 4 things, right, are not something that this claim actually exhibits, okay, then it may not be true. If it does pass all of these, then there's a possibility that is true, but should we take it at face value? And the answer to that is no, right? What we should always be doing, right, is constantly thinking about things and going through a cycle of continued growth, right, where everything is always subject to change. Okay, and that's really what we're talking about. What we're talking about is, are we able to come back, right, and evaluate a claim and really truly determine that it's something we should live by, we should go by, or we should actually use. Okay, so this is kind of the conclusion to the introduction of why we take a science class, why specifically maybe you're taking a chemistry class. Okay, and I hope that now once we transition into some of the different material, right, we might have a different perspective on why we're learning it. And maybe not approaching it with, oh, why do I have to know this? Why is this important? Right? Now we have a little bit of understanding why we need to know things. So maybe it's a little bit fun to delve a little deeper, right? And see what's really going on below the surface. Really start to look at things on a microscopic level and start approaching things a little bit different. So if we come to the conclusion of this set, right, we have our learning objectives. Okay, so I feel like most of you probably have a pretty good way, right, or have done a pretty decent amount of learning how chemistry affects the various types of daily life, how it affects your major, right? Hopefully we're able to identify some of these reasons and have a conversation about them, right? We also went through several reasons why we're studying it, right? Being safe, making sure we're not duped, right? Making sure we're understanding the things that we're putting into our body, understanding why we're doing some things or not doing some things, okay? We also talked about the difference between the technological and the philosophical. Okay, so the things that are theory, right? Or the things that are actually based on fact or based on experimentation. Okay, we went pretty deep into the 5 main things that science is, right? We went through how it's tentative, how it's predictive, how it's explanatory, right? What were some of the other reasons? It also needed to be testable, right? So it had to be a claim that you could actually come back and test, right? And additionally, it had to be something that's reproducible. And that doesn't mean that you should be able to go out and get the same result. That means that someone else should be able to go out and get the same result. Okay, we should also understand the difference between theories, models, and laws. The main challenges, which is basically just, it's not comfortable to us, right? It's also sometimes hard for us to take the macroscopic picture, the things we encounter on a daily life, and look at it more on a microscopic level. Okay, we also went through the scientific method and the main steps of the scientific method and how we can apply that to everyday life. So we should be able to, if I give you a problem, right, you should be able to walk me through a series of steps using the scientific method that would potentially come back and solve this initial observation, or it would come back and prove or disprove a general hypothesis. Okay, we also went pretty extensively through matter, what matter is, how it's broken up, how we're able to tell things about matter, right? We talked about solids, liquid gases, elements, compounds, our different types of mixtures. Okay, we also talked about the ways that we measure matter, okay, and why those things are important, and how we interact with those on a daily basis. So when you finish this, okay, I believe that this is all we're going to do in terms of what will be posted online. So what you guys should be prepared to do when it comes time for class when we return on Monday is just have the chapter 2 information on atoms printed, and we will get right into that when we get back. Have a good weekend.